Welcome back. What's going on? Today we're doing intro to Pwntools. In this video, we're going over task 4. In the previous video, we did task 2 and task 3. So task 4 is about performing buffer overflow exploitation on a program running on the running on the internet, right? So we have a program running on specific ports, and we know that the program is listening on a port. We will communicate with the program and see if we can overflow it. So here I have two instances. The first one I will connect to the machine, and the next one I will also connect with the machine. So in total I will have two SSH connections. Once you deploy the machine, you will be able to find the credentials. So let's connect. Password is buzz. This is first one. Next one also connect in another tab. Password is buzz. Okay, so we list the files, go to intro. Again, we go to intro. So the directory is networking. Go to networking. So we have three files. We have a C code, and we have the actual program that we will overflow, and we have a note. If you open the note, so the note says, I'm running a service on port 1337, which has an overflow vulnerability. I have left you a version that will run on port 1336 so that you can develop your exploit. So we have two programs. One is running on port 1336 and the other one is running on port 1337. We will target the program running on port 1336 just to develop our exploit for experimentation purposes. And once we know that the exploit is working, we will try the exploit on the program that is running on port 1337. So let's go over now the code of the program. So the code is in the file test_networking.c. So cat test, scroll up. Okay, we will not bother with these. Most importantly is to understand the following lines. So we have a function called target function. Takes an input from the user and stores the input in a variable called sockfd. Next, we define two variables. One is buff and the other one is print flag. The print flag is a variable and it is volatile. Buffer is kind of character, and the size of it is set to be max. Normally the max is 32. These two variables are next to each other in the stack, which means if you overflow this one, alright, you will be able to define the point after which you can also overflow this one with your own values. If you scroll down, you see here we have write sockfd give me dead beef, and then we have an if condition. If the print flag equal to dead beef, it will give you the flag. If it doesn't equal to dead beef, then it's gonna tell you buffer overflow, but there is no dead beef. So one condition to get the flag from the program is to let the print flag variable equal to dead beef. So in order to do that, we have first to overflow the buff, and then we add the dead beef on the print flag because these two variables are next to each other on the stack. So after understanding the code, and we know that there is a vulnerability in the code. Alright, so we know now that what is required to get the flag. We have to make the print flag variable equal to dead beef. Now for the buff variable, if we look at this line, you see max equals 32. So the buffer, or the buffer variable the size of the buffer variable is 32, which means if we write more than 32, we will make the program crash. So we will write 32 characters on the variable buff, and then we will add deadbeef so that it is written on the print flag. So for that, we need a code to communicate with the program. So the first thing, we run the program. So now the program is listening. We go to the next tab, the same SSH connection. We develop the code from here. So cd intro, or let's do it from here, nano. So the first thing we do, we import the Pwntools from pwn import start. Then we connect to the program. So we type connect equal remote. So since we are communicating with the same machine, we put the localhost IP address. And the port is 1336. We forgot one single quote. Now we will type a line here to receive just the data. If we go back to the code, the amount of data that's received is 18 bytes. So we type here print receive n 18. Next, we define the variable that will hold the payload. So payload equal so we type the A in hex, and then we type times 32 plus p32 Okay, so what we did here, we just added A's, 32 A's. So after we overflow the buff variable with 32 A's, we add the deadbeef. So that deadbeef will be written on the print flag. And then we send the payload. Connect, send. Lastly, we print the received value or values. The flag should be 34 bytes, of course, according to the code. Let's run that. Okay, you see we have a weird looking flag with all stars. The reason is, in the code, the flag is not written in complete form. And the reason for that is we didn't get the flag because we are doing that on port 1336. What we're gonna do now, and we know that the exploit worked, we will just modify the port and make it 1337. Run that again. And you see we got the flag. Alright, so let's go over the questions of the tasks and see what we need to answer. So first one, what port is serving our challenge 1337? Please use check sec on serve test. Is there a stack canary? So if you run check sec serve test, You see, most of the binary protections are enabled on the file. Although everything was enabled, we were able to exploit the binary for one simple reason, which is the variable buff was defined with a limited size, which can be overflow. It was 32. Next question. What is the flag? And here is the flag. So that was for today, and see you in the next video.